Hello, and welcome to another episode of the Code Breakdown. I'm your host, Andrew DuPont.
And I'm Brian Miller.
Brian, what are we going to be talking about today?
Well, it looks like we're going to continue with our discussion on testing types and talk about isolation versus integration tests.
Nice.
This time we're going to do things a little bit differently. Instead of spending the majority of our time writing the code with the test, we thought that we'd actually write out all of our code and a large majority of our tests so we can focus a little bit more on the explaining the different testing types. So what we have here is a smart thermostat, which I think everyone wishes they had in their homes. And the feature that we kind of focused on is this idea of calculating a cooldown rate and a cooldown time. So if you put in a goal temperature and you give it a current temperature, it should give you a rough idea of how long it's going to take to get from that current temperature to the goal temperature. And we added the outside temperature as something that will add a level of variance. Essentially, if it's very cold outside and you want to make it colder, it will obviously cool off faster. If it's hotter outside, you want to make it colder, it will cool down a little bit slower. So we went ahead and wrote some specs out for this, and I think we're going to start with integration tests. Does that sound about right, Drew?
Sure, yeah. So let me just run things to see where we are. Looks like we have two pending tests. One of them is an integration test, and the other one is an isolation test. That way we can kind of give a definition and example of each one. Let's start with the integration test, because generally that's what you do when you're doing BDD. So in this case, we want to drive through actual values from the outside level of our application, which is in this case is really calling the cooldown time method and passing it a goal temperature. The one requirement for this is that a current temperature has been set on the smart thermostat. So if we go down to our integration test, we can start out by doing subject current temperature equals 80, which is the example, and we can do subject dot cooldown time and give it a goal of 50, and we then basically now have an integration test, because what this code here is doing is just actually driving real values through. And by definition, an integration test is really a test that kind of executes or drives through multiple objects interacting with each other or functions interacting with each other. It's really just the act of driving through connected or combined code. So in this case, we have this top level cooldown time method. We can then see here is actually interacting with the weather service library through the get outside temperature method. It's also interacting with current temperature, which is an adder accessor method here. And we are also interacting with the calculate time to cool, which is another method within this class. So technically we are integrating into the weather service, we are integrating into ourself via current temperature, and we are also integrating into ourself with calculate time to cool. So this test right here, we can run our integration test and we can see that it runs. Now, if we were to break something, like let's say we were to get rid of this fetch temperature, comment that out, our integration test will fail, telling us that undefined method fetch temperature, because it's actually driving all the way through. If we look here, it's calling weather service get outside returns weather service API fetch temperature, and weather service API fetch temperature we just commented out. So if we uncomment that, we can see that our test is passing again, and we have one pending test left, which is isolated test. So here's our isolation test. Our isolation test is trying to test that it returns the outside temperature from the service. So in this case, we fabricated this scenario, which is we have this third-party web service API, and generally when you have a third-party web service API, you want to write a business logic oriented library that wraps that third-party API. This gives you a lot of flexibility in terms of testing because it would allow you in other integration tests to stub out this get outside temperature and have it return a specific value to avoid actually using the real third-party web service or whatnot. But in this case, we want to test that it returns the outside temperature from the service. So we can say that we want weather service API should receive fetch temperature. And well, that should happen when we call weather service, which is the subject. So subject dot get outside temperature. And we have a test that's passing there. Let's see it fail. Let's just return rand here temporarily. And all right, expected 1 time but received 0. Cool. So isolation tests are pretty much the complete opposite of an integration test. You can see what we're testing here is literally the behavior of this fetch temperature method being called. Our expectation is that we are waiting to see if this fetch temperature method is called, and everything else we really don't care about. If this function had another line up here that did something, and another line here that did something, another line here that did something, technically we don't care about in this particular test here testing either of those lines. We don't care about those because those should have other tests for each of those calls or interactions, right? That cover those. And the value of this is that when you have a failure, like we did here when we just had rand and commented out that, when we have this failure, we know exactly what the failure is. Whereas with an integration test, you won't know exactly what the failure is. You'll just know that overall your integration test is failing and that you need to debug it to actually identify what the issue is. So that's kind of the round of all of it. Therefore, you need really a balance of coverage of isolation and a coverage of integration tests so that you have both the specific failures as well as something that covers all the integration edges. And I think that's about it. That covers isolation testing at a basic level, and that covers integration testing at a basic level. What do you think, Brian?
I think that sounds great. And actually, I kind of wanted to pull back a little bit and cover all of the 4 different testing types that we've gone over with the last episode and this episode.
Sure.
As you pointed out, it's really interesting that isolation and integration are very much the direct opposites of each other, and state-based and behavioral very much kind of the opposite of each other. But they interact with each other. So isolation and behavioral are oftentimes used in conjunction with each other, and state-based and integration are oftentimes used in conjunction with each other. So you'll find that when you're doing, as Drew illustrated, when you're doing integration testing, that you are really looking at the state of your application at that particular time. And conversely, when you're doing a lot of isolation testing, you're looking at a lot of the behavior. So you're stubbing and mocking and trying to isolate so that you can examine how your app is behaving for a certain message expectation. And the really interesting point about this is that you really don't see a lot of integration tests that have behavioral patterns. So you're not going to have an integration test that's looking at kind of this higher level holistic view of an operation, and really you're not going to be very worried about whether or not a specific method or message was sent. You're really just looking at the complete state of an object after something's been run. And in the same way that when you're doing state-based testing, it's not very common for you to go in and do any type of isolation. You really want to see what an object looks like after an operations run. There's not very many cases. There are cases where you might want to do that, but there are not very many where you're going to actually go in and stub or mock out certain levels of your object, because that actually may produce incorrect state and make your test rather brittle.
Yeah, definitely. It seems like the one scenario that I see relatively often, which is what some people refer to as an isolated integration test, and that's kind of the awkward middle ground of these things. And in that concept, you're really isolating kind of two layers of depth deep in your integration, and you generally use that to test a specific test point of integration, like test the integration of a specific method call and not worry about the integration of other method calls. And the value of that is that using that isolation to test that integration point will tell you that when that specific test fails, you'll know that specific integration point is not being integrated properly, right? Either the library that you were trying to call, maybe they changed the definition of that method when you upgraded, or something like that. So I think that covers it for this episode. Until next time, that's the breakdown.